This video is a follow-up to my three-part series with the head of engineering at INEOS Automotive. So if you haven't already done so, please watch that first, because that way this video will make more sense. I've also got a three-part series with the Asia Pac INEOS boss, which might be of interest, and a whole heap of other content like my LC300 engineer interview and various other INEOS and Grenadier content. And I would like to sincerely thank INEOS Automotive Australia and the UK for making this interview possible. It's not often you get to speak to someone that senior at an engineering level, and I'd like to say thank you. I think we can all learn from that, and hopefully it sets an example to other car makers, because us enthusiast car owners just want information. We just want to understand how these vehicles work, and that's especially important in the case of the Grenadier, which is used as a tool, and in some cases information can make the difference between life and death. Now, a little commercial as well. I do have a shop on Redbubble. There is now a Grenadier design on it, which may be of interest to INEOS owners. So these are clarification points coming out of that three interview series then. And here's the first one. I talked about graceful degradation, which is a concept I use to mean that certain parts of the vehicle can fail, yet the vehicle still carries on, which is something we don't often see with modern vehicles today. Sometimes, for example, a sat-nav failure can bring a vehicle to a halt, which is just unacceptable, I think, for any vehicle, particularly on off-roader. So the question I asked was, if a wheel speed sensor fails, will that bring the vehicle to a halt, i.e. would it put it into limp mode, restrict the engine, etc., when there's really no need for it, particularly not in a vehicle like the Grenadier, which has a centre diff lock and cross-axle lockers? And the answer was no, a wheel speed sensor wouldn't do that. So that's great. That's not the case of many other vehicles. I then asked, can you give us any more examples of things which could fail and the vehicle keeps going on, and whereas with other vehicles that wouldn't be the case. And here's the clarification in addition to what was said in the interview. So one example of this is that the display can fail, but it will not stop the vehicle. Key ECUs that will stop the vehicle is the ETGW, entry and terminal gateway, and the BCM body control module, but these would have to be completely broken or fuse stopped to damage the vehicle, or to stop the vehicle. And I also note, in addition to that answer, that the centre diff can isolate a front or rear. So if you break a CV, for example, you can lock the centre diff and you can drive the rear wheels. I think that's important. You can't do that on vehicles with, or not easily anyway. I certainly had that experience, vehicles with a smart centre clutch. So it's not a complete answer, but I think we can be fairly sure that the Grenadier is probably better designed for graceful degradation than the average vehicle. Now, a couple of other points which came out in the answer. This is called, the main display is called the HMI, Human Machine Interface, and the smaller one over here is called the TTC, the Telltale Controller. I didn't know that. There's a bit of trivia for you. Then here's a question many people are very interested in: OBD2 scanners. So these are the ones you can plug into the OBD port. You can read diagnostic codes, see what's happening there, and also get a whole load of data as well to put it on a display. And then you can also clear the codes as well. Very, very important bit of kit to have for any modern vehicle, I feel. So we discussed that in the interview. The follow-up question was, can consumer-grade OBD2 scanners be used to read and clear fault codes? That was the question. Now here's the answer. Some generic apps and OBD2 dongles can read the Grenadier DTC's diagnostic codes, and some can even clear them. So that's good. I think it's just a case of seeing what your particular scanner can do and trying that. Patrons and YouTube supporters do have a discount with AutoFix Australia if you want to buy a scanner, but I do want to emphasize at this point that do not clear codes without fixing the root cause. So if you clear a code, that can actually get you out of significant trouble. And there was a case in my club recently. A car was stuck on sand dunes, had a failure, couldn't drive off it, cleared the code, drove off the sand dunes, even 5k, able to get on a tow truck. That's the sort of stuff I'm talking about, let alone being able to understand what a check engine light means. So I think OBD2 scanners are really important, but do not just randomly clear codes without understanding it. Always go to the root cause, please. And there are generic codes which work across all vehicles. They're industry specific codes, so if you can, try and get a scanner specific to your vehicle, and there's not one for INEOS I'm aware at the moment. Maybe the BMW scanners would. This is probably something that needs to be investigated by an INEOS enthusiast. So then we come to cross-axle lockers, and the background for this is the cross-axle lockers are only available in low range, and you have to do the classic centre, rear, front sequence, and they don't work with hill descent control. There's no brake traction control on the front axle. So that is actually pretty normal for OEMs. There are exceptions to this. Ford, for example, allow you to lock the front axle on the Bronco, but not the rear. There's probably some other exceptions which I've forgotten, but that is pretty typical for OEM. However, the question I had for INEOS is, you specifically said all over the place, and even at interview, we will give the driver maximum control. So why can't the driver have control over the order of those lockers? Why does it have to be centre, front, rear? And that was my question. I would not have raised that if INEOS have not specifically said we're going to give you driver control. So here's the answer that I got back. When driving uphill, the physical axle load shifts to the rear. Yes, that's definitely correct. Front axle overall grip capacity is reduced. Yep, absolutely. As a result, rear diff lock offers more grip here. Yes, no question about that. When steering is required, this can be impacted by activation of the front diff lock. Yes, okay, that's fine. So all of that is correct, but it doesn't directly answer the question as to why we don't have that. And then I think the next question is why it actually need it. So let's talk a bit about that. Now, centre, rear, front works. It's the OEM, it's standard, it's the safe thing to do. It actually protects the drivetrain a fair bit, because, and also the driver, because if you can lock the front only, even without the centre diff locked, you can get yourself potentially into hospital, because then you could try and drive a hill in low range with the front locked. Front wheels will spin, lose traction, the vehicle yaws sideways, you go down the hill into hospital if you're lucky. So there's good reasons to protect the drivers from themselves and the drivetrain for doing it, but we are talking driver control here. That's INEOS's principle. So there are some cases not to do this. I'm just going to run through now. They are niche cases, and probably only for the more hardcore drivers, but nevertheless they exist. So essentially, it's whenever you have traction on the front wheels but not traction on the rear wheels, or limited traction, which does happen off-road. You can have two wheels on a rock ledge and then one wheel hanging off the edge of a slippery rock or something like that on the rear, and you really don't want to put any torque through the rear. So for example, when you are going up a really steep hill, if you just put the rear in, the vehicle will yaw, and I do have video examples of that. So therefore you'd want to go twin, which the Grenadier can do, or front only, and sometimes it can get to the point where you really just want your front only pulling you up, and you don't even want the rear engaged. And it comes back to the traction circle and grip budget. You've got a certain amount of budget on each tyre, and if you start using that budget to push you forwards with the rear locker in, then you're not using that grip to stop you sliding sideways, and that can be problematic. So it's a niche case. It doesn't happen often, but it does happen. Then this was actually raised by one of my patrons. You want to be able to spin the vehicle round using the front lockers. Well, how does that work? Well, let's say that you're on a narrow track, you're driving up and you put your wheels up a ledge. You just apply a bit of wheel spin and the car pivots around because it loses traction on the front axle. That is actually a technique. It is used, right? I've done that quite a bit using the rear, just to literally spin the car up and then just pivot it round, and that is a valid technique. And again, it's niche, right? But when it happens, it happens. Steering with one front wheel in the air. So you're coming around a really steep corner, and even locking the rear will actually increase your turning circle. Now, if you've got your front axle, one wheel is in the air, one wheel's on the other wheel's on really good traction on your front axle, you can use that wheel to just pull you around, and then you don't have to worry about the rear axle just pushing it that little bit further. So there's another example. And side slopes. Now, on a side slope, any use of lockers will slide you sideways, but the front less than the rear, because obviously you can turn the front wheels. So whereas the rear will almost certainly sort of slide the back down, whereas the front, because you can turn the front wheels, has less tendency to do that. And again, edge cases here. And the other thing is failures. So again, if you've got something like a snapped front CV, or you've got some form of drivetrain problem, it's actually really handy to be able to selectively put lockers in. So let's say that we've got a problem with the actuator on the rear diff, so the rear diff doesn't work. That means the perfectly functional locker on the front diff won't be activated because it's waiting for the rear to come in first. Now, if you had them independently selectable, you'd still be able to use the front even though you've got a problem with the rear. So those are just some examples examples. There's probably others. I'm interested to see more in the comments. Now, in high range, why do you want the lockers in high range? Well, first one is rutted sand dunes. In sand dunes, often you can go into high range a bit. You're coming up to a rutted sand dune where people have just spun it out because they're idiots at 25 psi, and you know, you just whack, bang, lock it in, up you go, and then you're doing less damage, you're doing less wheel spin. Easy, right? But you can't do that in the Grenadier. Now, I do that all the time in my Ranger. You know, I just bang, in goes the locker, up I go, out again, and I've just done less damage to the track. I don't want to have to stop and put my car into low range for that sort of thing. Crisscross sand on beaches, particularly if you're towing. So, you know, that's when there's tracks going here, tracks going there, tracks going everywhere. You're coming over and the vehicle's doing that. You don't want to lose momentum, and if you don't have your lockers in, you can actually lose a little bit of momentum. So there's another example in high range. Riverbed climax, and this is something that I really got annoyed with about Land Rover, lowering the car at 50 kilometers an hour. So this is in the outback where you're going along, you're doing 50, 60, 70, maybe even 80 k's an hour on a very good sort of dirt track. It's flat. You wouldn't want to be in low range for that. You come to a creek washout, you go down into the washout, up the other side, it's a little bit rutted. Of course, you could make it without lockers. You could, right? The Grenadier is a capable vehicle, but it's nice to be able to just pop the locker in, and again, you're doing less damage to the track because there's less wheel spin, and that rutted climb out, you know, it's just done. And you come out the other side, accelerate away, press the button, bang, done. So that's another example. And again, interested to see your comments. And then the other point is when you cannot get into low range. Let's say that you're out on the tracks, you've got a problem with the vehicle, it won't go into low range, but you really need to drive it out. You want to have your lockers available in high range if for whatever reason the vehicle won't go into low range. So again, that's kind of graceful degradation there as well. But yeah, so centre rear front works 99% of the time. It's the safe option for the driver and for the vehicle. There's good reasons why that's done, but yeah, it's the driver control thing. And also there's no front brake traction control on the front axle when the rear locker is engaged, and I think there should be, because that gives you the best of both worlds. You get a rear lock and you get the front helping you as well, and it doesn't restrict turning as when you put the front locker in. But yeah, the only reason I'm focusing on this is because INEOS have said driver control over rear lockers.
Anyway, front versus rear lockers. Look, the simplest way to think about this is if you've got a wheelbarrow full of bricks and you need to get it up a step, is it easier to push the wheelbarrow up the step or pull it up the step? Now, the answer to that is obviously pull it up the step. And that's when you start thinking about whether you should have a front-only selectable locker or a rear-only selectable locker. If you have a front-only selectable locker, it's like pulling the vehicle up the obstacle, up the step, like pulling a wheelbarrow load of bricks up a step. The front, even though it might have less traction, it has more effect on the chassis of the vehicle. So I love to be able to have the option to select a front locker only without the rear locker. And sometimes it's because the rear is going to be screwing itself around and so on, and causing slip issues on rock steps or rock faces or whatever I'm trying to climb. And just allowing the front keeps the vehicle straight and centered and pulls the vehicle up over the obstacle.
Now, rear lockers and hill descent control. This is something else which I think is, again, potentially a missed opportunity. And essentially, use of hill descent control, rear lockers. Why can't the lockers be used when hill descent control is activated? Here's the answer. Mechanical lockers like those fitted to the Grenadier cannot be engaged or disengaged in real time. I don't really understand what that means. I mean, I guess it means just quickly. So it's not possible to brake each wheel individually as is needed in downhill conditions with HDC. Not the case. HDC just brakes all the wheels to a set speed. If all four wheels are rotating at the same speed, HDC will still work. The other thing is that you'd want to be able to, and this is mainly the use case, but you want to have HDC operating when the rear is in only. And the reason for that is that when you come down a hill, which is very rutted, you're lifting wheels, it's actually advantageous to have your lockers in, or at least the rear locker in, because that stops the vehicle running away. And I've got a whole video where I actually proved that exact point. And it would be nice to have HDC on the front, on the vehicle as well. Not essential. Now, and also it can be done. So many other manufacturers allow a locker and HDC, so it is actually possible. Now we come to the footrest. Now, so yeah, we all know about the footrest, right? So what's the deal here? What would it take for it to be solved? And here's a quite interesting answer. Due to the different body styles of the Grenadier versus BMW cars, the fitment and placement of the engine is different, okay? Get that? INEOS Automotive has prioritised off-road geometry. Good, that's great. And removing the footrest would impact on the ramp over angle, as the wheelbase would need to be increased by 100 millimeters. So there you have it. Would you like 100 extra millimeters in the Grenadier wheelbase? I don't know. Maybe you do, but the thing is, that would actually be 100 extra millimeters at the front, not just extended at the rear. So just to be clear on that. So there you go. That's the answer why. I guess you're going to be stuck with that until there's a different engine in the front. I'll probably fix it. Now, Winch did ask a little bit about the winch, and this was a clarification. There was a statement made in the interview that INEOS were the only OEM to provide a winch, and at the time I thought, I don't think that's right, but maybe things have changed. So I went and looked it up, and I found that Jeep, Land Rover, Ford and Toyota all have factory winches. So clarification from INEOS is here, and it said that INEOS Automotive is the only OEM to provide the front winch in the EU from the factory, and they are not the only one to provide it where there's no pedestrian safety. We don't have pedestrian safety standards in Australia, so that clarifies that one. Now bear in mind that the winch is a bit limited, but at least they have a winch. So that's part one of the clarifications. In part two, we're going to be looking at ESC and brake traction control calibration, the dual battery setup, advice for INEOS owners, and INEOS's message to the world.